now you have already defined the write address master driver, and next you are going to derive the write address slave driver. So this is another zoomed version of write address master driver. If you want, I'm just pausing here just to make sure that the code is visible for you. So this is the code until the run phase task in the master driver, and this is a task for waiting on reset, initializing signal, and this is a task for managing a sequence transaction, and finally this is the task for driving write address. Alright, next we'll see the write address slave driver. In case of the slave driver, when the agent is acting as a slave, the signals, all the signals in this write address interface, which are WID, address, length, etc., will be coming as input to this slave, and the only signal that is going out of the slave will be this ready signal, AW ready signal. So since it is an AXI masters AXI protocol, since it's following an AXI protocol, in the slave mode you just need to drive as ready signal. So to make things simple, our slave driver is a simple driver which will drive slaves ready signal randomly. But if in the actual DUT, if your functionality of the DUT slave is to drive something else, then you need to drive the exact same kind of slave driver as you had written in the case of a master driver. So here we will make your slave driver as a simple driver which will drive the ready signal randomly. So here is our AXI write address slave driver extending from the UVM driver. After the UVM factory, the members are the interface and the config. So in case of slave driver, the config is required because we need to decide how we want to drive ready signal. And after the new and build functions, the next is the run phase task. First we will check for the interface, then we will initialize the signals and wait for a reset. So this is a very simple logic, since we are not expecting any mid-sim reset in case of a slave driver which is driving randomly. You can just wait for a simple reset and drive the ready signal. And in the drive ready part, what you are doing is, if the config is saying to drive ready always, after a clocking block delay you will drive the ready as 1 and wait for another clocking block, and this is not repeated anywhere, so this will be always ready and the task will be executed from here. But in normal mode, when the config is not set to drive always ready, you will drive the ready as randomly. So forever begin, get a random delay, wait for a clock, repeat random delay, and interface, toggle the interface ready to the new value and repeat this forever. So the slave will be driven randomly. So this slave driver is a simple driver. This is slave driver. This is not responding to any sequence request or something. But while you go through the agent of a write response channel, that is, while you are writing for the AXI write response agent, you will actually see how to write slave driver for a response, slave driver for an agent which is actually responding to something. But in this case, this is a simple slave driver which is driving the ready randomly. The next one is the monitor class. This is again an important class. You should always write a monitor along with every agent, whether it is a passive, active, or mix of that. In the monitor class, which we will be extending from the UVM monitor after the factory registration macro, the members of the monitors are a virtual interface and an analysis port. So if you remember the diagram from the previous slide, the monitor has an analysis port, and it need to be connected to the analysis port that is sitting within the agents. So the monitor has an analysis port to which we are writing transactions that is collected from this interface. Now in the new function of this monitor, make sure that you create the instance of this analysis port. So this is something that you haven't seen in the sequencer or the driver. But since we are explicitly adding an analysis port here, you have to create the object by using a new function. There is no need to use the UVM factory type here because this is a simple analysis port. In the run phase, first you'll check for the null handle. then wait for the reset. Then you will call a task which will monitor your write address, which will be looping in a forever loop. So this is a monitor write address task forever at the monitor clocking block in the interface. If the interface is valid and ready, you will create a new transaction. Transaction.channel is write address, RW is write, ID is equal to, that is coming from this interface, length is coming from the interface, and the address is again coming from the interface. And if you want, you can print this info by using the convert to string function in the transaction. Then finally you will write this transaction into the airport. So mairport.write will send this transaction into this analysis port. So this is the implementation of an AXI write address monitor. This is pretty simple because this is everything is completing on a single clock cycle, as this is AXI write address channel. The next part within that agent will be a coverage collection component. So as you can see in this figure, this is a coverage collection component. So actually we are not implementing this checker, but we will be implementing this coverage collection component. And this component will be collecting coverage per interface. So this will be just monitoring this coverage on the transaction that is received in this interface. Now here is your AXI write address coverage collection component. So it is AXI WR ADDR coverage, which is extending from the UVM subscriber. So you should note down this is extending from the UVM subscriber parameterized with the base type. And after the factory registration macro, what you're doing is you're defining a cover group with very few minimal bins. This is just for illustration purpose, so I haven't defined all the comprehensive coverage for this interface. I'm just defining a coverage for the transaction, few fields in the transaction. Note that this MTXN is a member of this class, and we are sampling coverage on this MTXN type, an MTXN member. So it will be, if you wanted to sample the ID, you will be sampling like the cover point will be written like mtxn.id, and in the same, if you want to sample address, it will be sampled on the mtxn.addr. And this is a cover group with name AXI_WR_ADDR_COV. And within the new function, after the super.new, note that you are instantiating this cover. So after defining a cover group in Systemverilog, you need to create an explicit instance of this cover group. But when you're defining a cover group within a class, it is a different case. So you can use the same name. You don't need to explicitly define an instance of this coverage like AXI cover1 COV1. It is wrong. It will give you compile error. You don't need to do that. But what you should do is you should explicitly call the same name, the name that you have used to define the cover group, that is AXI_WR_ADDR_COV. Same name, and you should call the new. So this is specifically for any cover group that is defined within a class. You cannot instantiate cover group within that class and call it. And next function is the write function. It's a virtual void write function, which is getting the transaction as the AXI base. As I said earlier, this class, coverage class, is extended from the UVM subscriber. Since it is extended from the UVM subscriber, it has already got an analysis port implementation named analysis export, and therefore you don't need to write explicitly an implementation here. But if you are using instead of UVM subscriber, if you are using a UVM component, things will be a little more complex. You have to define an implementation of the analysis port as you had seen in the previous diagram. But since it is extended from the UVM subscriber, you just need to call write the functionality within the write function. And within the write function, what we will do is this is a function that is getting called every time when a transaction is returned into the analysis port from the monitor after connecting appropriately. So every time when a transaction is returned from the monitor, that transaction will be coming as an argument to this write function, and as it is assigned to this MTXN, all the new transaction fields will be automatically get sampled by this cover group. So the only specific things about this coverage class is, one, Ideally, you can extend it from the UVM subscriber. And the next thing is, it is general for any Systemverilog coverage that is defined within a class. So the cover group name explicitly need to be nude within this new function of this class. And in the next movie, you will be learning about how to connect these things together according to the configuration, so that you will be writing your final AXI write address agent